All right, so Louie, they got a Bernie's. Yeah, and it's a I was gonna say a little puppy. It's a young puppy, but it's not little. So here's Louie. Huh?
This was on your slide yesterday for one from like EO2 or something.
Exactly. How'd you know that?
Because I went in after to like get to my locker and it was up.
Oh, was I saving it? Yeah. That's because no one sent me pictures. And I was out of gray super pictures, so I need more pictures. Okay, so let's see. Okay, I'm just sort of like setting the stage for everything we're going to do. So now I'm going to go to. All right, now we'll come back to that. So if you will look at number 4 in your packet. Number 4 in your packet. And have your calculator out. You don't have to write anything. You can if you want to. I'm not going to ever take this up. But I'm going to call on you, hopefully by name. So I don't want to put you on the spot. Or I tell you can, well, if we raise your hand, y'all are also eager, you'll all raise your hand, then I can't pick. So I'll probably call on a few people by name to give me a value, but just keep up. I think we learned yesterday we want to put these in parentheses for now, for this investigation. So if everybody will type into their y equals, or does somebody need a calculator today? Okay. Grace, are you borrowing one?
I borrowed them from a friend.
And so is it all set up to go? Okay. And Brianna, are you set?
This was Eric. Yeah, homework. I used the fraction, and it works with.
And it works with decimals.
Yeah. So I think it just like took a while to like adjust to.
That's so weird. I've never seen that happen, so that's good to know. I don't know. Okay. And I've done it a long time. Okay. We are all putting into our whiteboard y equals x plus 1 over x squared minus 3x minus 4. I'll be careful to write where you can read, but right now you've all got it on your paper. So if you can't read it over Louie's face, then you can look at it on your paper. Make sure you type it in correctly. One of the biggest parts of your calculator skills is making sure you have typed it in the right way. You'll notice on quizzes or tests, sometimes different versions. Hopefully you won't look at your neighbors, but if you ever did, you might go, oh my gosh, we've got the same test. But all I got to do is change one sign in there or one number, and it's a completely different rational function graph and problem. So you don't want that to happen to you when you are trying to do your homework. So make sure you double check it, look at it, and also watch me when I'm typing them in to the computer to make sure I've got it right, the calculator. All right, let's see. Elena, okay, I'm going to graph as y'all give me numbers. -10, -20, 10, 20. All right, Elena, give me -20, and y'all all double check each other.
-0.046.
All right, so it's going to be really hard to graph that point because it's really underneath the axis, but incredibly close, right? If this is 1 and this is -1, okay? -10, Katie LaPola? -10?
Yeah. -0.0714.
Again, really hard to graph. They're very close to 0 on the negative side. All right, -1, Zainab? Error. Oh, wait, so I've got one of the, there's really 3 things that can happen with an error, probably more.
So it doesn't like.
Is sometimes.
Is it the like coefficient of the like top x value? As like.
Oh, that will make a difference. But what about something else that's undefined that doesn't have anything to do with fractions? When else have you run into error or undefined?
Like when there's a whole.
Right, good. I'm glad you know that word. That's where we're headed. What about the square root of a negative? Okay. However, those aren't. There's complex numbers that we'll study later in the year. Let's keep going. All right. So now I'm going to kind of go off road here, and if somebody would put in 6, Lauren, 6.
45.
What was it?
45.
0.5. Okay. Let's see. Brianna, 7.
0.333.
Okay. All right, and let's see, 4. I want to do 2 more. Let me think what they are. Let's try. Let's see, Isabella, 15.
809.
Okay, so it's still really little. Let's see. Have we done 5? Do 5, Danielle. What's 5? 5 is 1. Okay. All right, would y'all agree that if you did these graphs like you traditionally did graphs where you just find points and connect the dots, this is really going to be a long process? All right, so asymptotes are your friend. Okay, asymptotes are your friend. Remember, they're going to give you guidelines like this. I think you all did that. Did everybody do that project up there? Maybe not.
No.
Did anybody in here do? Oh, that was that. Okay, a few of you did. Okay. Let me find one. Let's see. Here's one. I think Grace and Danielle and Lily, yours looks sort of like this at some point. Is that right?
Yeah.
Okay. All right. If you can imagine, you did one too. Okay. If you can imagine if Miss Cece had handed to you just a sheet of paper in that shape with, well, you had to make your own. Anyway, you had to make your own sheet of paper. But suppose that the first day that she came in and said, we're going to make these awesome, like she held up her incredibly awesome box with the fuzzies on it. And she said, you're going to make this, and she just handed you one of these things with no lines on it, 0. And speaking for myself, I wouldn't have any idea what to do or what it was going to make. But what are you going to do on those lines?
Fold.
You're going to fold. You've all folded on the dotted line, cut on the dotted line. I think I introduced this the other day. I can vividly remember when I was a little girl and I went to vacation Bible school. Anybody go to vacation Bible school or her church? In the summertime. In the summertime, it's called, is it still called vacation Bible school?
Yeah, that's a lot.
So for a week, you do all these like fun things and sing songs and make crafts. But I wasn't very crafty at the time. And I remember that I thought that I was crafty because all of a sudden I thought it had hit me. Because they gave me like this sheet of paper on Monday and said, take this home, or maybe in the class, we made it into a church. And the little leader person held up this church with a steeple and everything. A little slot in it, we would put our money in for missionaries and bring it in on Friday. And I thought, I could never make that church. But I'm very conscientious, and so I cut and folded and taped where it told me to, and guess what I made? Thank God, literally, for the guidelines, okay? So, thank goodness for the guidelines, okay? So let's get us some guidelines. Guidelines are our friends because all of a sudden it's going to enable us to do what we need to do. So don't shy away from them. A lot of graphs don't have guidelines. The funny thing is once you start asymptotes, there's some graphs you encounter that you kind of wish you had one or two, because you're like, I don't know what's going on. Our asymptotes are going to come from, they're always lines. There is something I'm going to tell you today called in behavior. An in behavior model. In behavior model, an asymptote is one of the in behavior models that we have. Okay? So I'll get to that in a minute. All right, now what do I mean about thank goodness for dotted lines? Sandy?
I have a question.
Okay.
Do you have a definition for asymptote?
A guideline. Guideline for your graph to follow.
Thank you.
You could probably look up a like super formal definition in your book, but all you need to know is it's a guideline that your graph will follow. Your graph can touch it, it can cross it, but it's a guideline for it to follow. The only one it can't touch is a vertical asymptote. What three types of lines do we have? Vertical, horizontal, and a slant. That's all we got. So those are your three types of asymptotes. We'll write those down later today. You don't have to do that right now. But I'm going to find my guidelines. One way to find my guidelines is if the bottom will factor, I'm going to factor it. You should wonder what if it won't factor, because you're smart enough to know everything in the world won't factor. Some of you know how to find out what makes it 0 on your calculator without factoring. And we'll work on that later, not today. All right, so just know that a lot of things won't factor. Just because it doesn't factor, does it mean it doesn't have zeros?
No.
Good, I used to think that meant that. It just means it's not going to have any I'm going to think of real quickly, okay? They're going to be ugly probably. So I'm going to put 4, 1, minus, plus. Y'all okay with that? All right, so what makes this 0?
4.
Look at this. What makes this 0? There we go. There was the two places it was undefined, okay? Now what I'm going to do is I'm going to fill those into the numerator because my calculator gave me error for both of those. What happens if I fill 4 into the numerator? I get 5 over 0. This is a no-go. Nothing is going to happen here. There is going to be absolutely no answer. And so I have a vertical asymptote at 4. Sorry, that's not how you write it. I have a vertical asymptote at x equals 4. You have to say the x equals for me. Vertical asymptote at x equals 4. So my dots are so crazy here, I'm going to get rid of them for a minute. Vertical asymptote at x equals 4. Now what I do is I strongly suggest, and every time that you graph, that as you find things, go on and draw it. Don't wait until the end. That guideline is going to help me a ton, okay? Everybody look at your calculators real quickly. Go to the table, fill in 4, do you get error? Okay. Fill in 3. And, okay, go back to 3. 3, you got -1. Okay, now go back to 5, you got 1. Now put in 4.5. 4.01. Okay, so I'm getting closer to 4 and I'm getting carried off to infinity. Do y'all see that? Okay, it didn't look like it at first, but until we know to investigate what's going on at this weird place 4, it's going off to infinity. You'll find a few points. You don't need many. The good news here is you don't need many points once you've got your asymptotes in place. Oh, let me pause for a minute and go to some